Hello, guys. Welcome back to the Structural Geology lecture series. In today's lesson, we are dealing with the continuity and discontinuity in structural geology. This is MG School of Mining and Geology, the only school we are striving for excellence. Please don't forget to like, share, comment, and hit the notification button below so that we keep producing this kind of content. And if you have any topic that you'd like us to cover related to the structural geology, you are more than welcome to mention it in the comment section, and we'll make sure it's part of the structural geology series. Let's get right into it. Now, the continuity refers to the uninterrupted extension of a geological structure or feature of a distance. And then, but now discontinuity refers to the absence or the interruption of refers to the absence or interruption of the geological structure or feature of a distance. So it means continuity, there must be no eruption, and then with the discontinuity there must be some interruptions. All right, so I hope you understand, which is why we're saying refers to the absence or absence of the geological structures or the interruption of a geological structure, right, over a distance. Discontinuities can take many forms, including faults, fractures, faults, and of course unconformities, and we're going to look into this as time progresses. Now let's check these layers, and then if we can check over here, we see the layers, which continuous. They're gonna come back here, come back there. They are continuous. They are continuous. So these layers are continuous. So it shows that we are having an interruption. All right, we don't have any interruption. So but now, if we are looking at now this a picture over here, the joints, they are continuous because they are not interrupted. All right, but now here, these ones, they are discontinuous because we expect these to keep going, and then combine with this one. But no, it's not the case. So it means these ones, they are discontinuous, but these ones, the joints are persistent. It means they're continuous, but these other ones, they are not continuous, they're discontinuous. But now let's look at also the boudinage. So look at here. Okay, look over here. This bedding, it's continuous. All right, but if we check, we look at the structure called a boudinage. It's not continuous. This it was like this. It was this thick, and then now they're pinching out. They thinned out, and then now again they thinned. They are not here. They are not discontinuous. Then basically, what is a boudinage? These structures called a boudinage. It's a geological structure where the competent rocks, these rocks over here, they are competent, where the competent rock layer deformed into a sausage-shaped, bodies or lens-like shape compared to the incompetent surrounding rocks. So these rocks, they are incompetent, and these ones, they are competent. And then now these ones which are incompetent, these ones that are competent, they're gonna now they're going to be deformed into sausage-shaped bodies. All right, so these ones, they are incompetent, the surrounding rocks, and these ones are competent. And then now boudinage, how does it form? Usually, this Budnaj structure is found in strongly deformed sedimentary and metamorphic rocks, right? And then wherein an original continuous competent rock, for example, this one, because this and this rock are the same. This was a continuous, this was a continuous competent layer, okay? Okay, this was a competent layer, and then forming a bed with the incompetent layers, and these are the incompetent layers. So then what really happened was the competent layers were being stretched, then now thinned and broken at regular intervals. At the regular intervals, they were broken, they were stretched, thinned, and broken at the regular intervals, now forming what we call a body notch. So now you can now see that now these things, they are not continuous, but they are discontinuous, which is why as a structural geologist, you also need to understand the homogeneity and the heterogeneity of the structural features. Okay. So the structural in structural geology, continuity and discontinuity are important for reconstructing the geological history, understanding the structural evolution, identifying the potential hazard, and the target exploration. Now, by studying the continuity and discontinuity of different geological structures, geologists can reconstruct the geological history of an area, including the timing and the nature of the tectonic events. All right. It means, for example, let's check at what you call, let's say this was like that, and then due to the effect of erosion, it was eroded, forming a valley through which now a river can be able to now flow. Now, okay, now it means if the layers were continuous like this, the layers were continuous like that, now they are discontinuous. It means that we expect this to also continue to that direction, but over here is not there because of the effect of erosion. All right, now it means if we understand this discontinuity, the geologist will now be able to reconstruct, oh man, this layer the same as this layer, there must be one thing. All right, there must have been one thing initially. Now, continuity and discontinuity help us understand how geological structure evolved over time, including the formation of faults, faults, and other features. I mean, you'd agree with me that when we've got the directed pressure, and then the rocks, they start to so let's say it was like this, and then you compress this, then this will start to show some faults. Okay, will start to show some faults. But now intense ones will make now this I'm sorry, this is exactly what's happening in the greenstone belt, and now these things would now extensively become folded. Right, will extensively become folded. So and then you need to understand the language of continuity and discontinuity to know to understand how geological structures have evolved over time. All right, now with time, these folds, they would now become overturned. This fold will now become overturned. So you now need to see, because now these, I can see now these folds are continuous, but now if they become overturned, they would now start to be becoming discontinuous. So you need to understand this language for you to understand how these structures evolved over time. Now, by recognizing discontinuities such as faults or fractures, geologists can identify potential hazards like earthquakes. I mean, we know earthquakes, if we've got some, and then the epicenter, usually it's along the plains of weaknesses, right? And then yeah. And then also, if we've got extensive fractures, then we know, especially in the slopy regions, now we know that those rocks, they are susceptible to falling, then they would fall. And then also if we've got this slope, and then the rocks over here, they are not stable enough. Okay, the rocks over here are not stable enough, they would now be able to form. So it also needs the understanding of the heterogeneity and homogeneity. Continuity and discontinuity can guide exploration efforts by identifying areas of potential economic interest, such as mineral deposits or hydrocarbon reservoirs. Okay, so I hope you understand that the heterogeneity and homogeneity, they are also important for the structural geologist. All right, and then techniques used in the field, you have to perform what you call the field mapping, wherein a geologist is creating a detailed map, okay, of the geological structures. Now, by observing distribution of rocks, their orientation, and their relationship with other features, then you create what you call a geological map. All right. Now, the structural analysis, geologists analyze the geometry of faults, faults and other structures to identify patterns and relationships that indicate continuity or discontinuity. I mean, for the faults, we're gonna be looking at the hinge lines, all right, and then we're gonna be looking at the hinge lines, and then these hinge lines, the ones that divides the 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 limbs, and then this would tell us much about the continuity or discontinuity of such faults. Okay, and also for the faults. Right now, the geological logging, geologists can collect detailed information on the rock units encountered during drilling or coring operations to identify changes in the rock type, orientation, of the properties. I mean, we know if we're looking at the core, and then we can log it and then understand the homogeneity. If we've got from, let's say, 0 to 10 meters, we've got the same chemical composition, same structures, and many other things, then we know that particular core for that particular depth, it was homogeneous. But from 10 meters to about 25 meters, now maybe we start to see different chemical compositions, textures, and many other things. Then no, it becomes heterogeneous. Now, geologists use seismic surveys to image the surface structure and identify potential discontinuities like faults or fractures. Okay, so yes, because we know if we've got some faults, then we know the seismic velocity would not travel fast because of the rocks. Now they are not stiff, they are not rigid. Now that's why seismic surveys can also be crucial in understanding the discontinuities, and then these faults and fractures, they are very important. Not only they are very important in geology, because now the faults and fractures are the pathways through which magma can be able to pass through to ascend, and now as it crystallizes, it might crystallize with economic important materials. And these fractures, they're also good for hydrothermal fluids carrying metals, and to now be able to pass through. And then when physical and chemical conditions changes, then these materials like gold, silver, and many other things, they might get out of solution, be precipitated and concentrated there at a particular region for over millions of years, and then forming some ore deposits. So all these things, they need the understanding of a structural geologist who understand the continuities and discontinuities. Okay, a geologist in the field can make observations about the texture, composition, and orientation of the rocks to identify patterns that suggest the continuity or discontinuity. This is one, is the obvious one that you must get in the field. I mean, let's check at the seismic method. You send the waves on the ground, and then because we have got the first layer at the top, we've got the first layer at the top, we've got this layer, we've got that layer, then we've got this boundary. Then we know you can either have a refraction or we can have a reflection. And then these are the geophones which record the seismic waves, and then we've got these ones. And then for example, in the if you for the geotechnical engineering purposes or the engineering purposes, the rocks which are fractured, these waves will travel very slow. All right, and then it will take time to reach the geophones. But if they are not fractured, they will travel fast, and then they will arrive here fast. And then by so doing, we'll understand what's happening below the surface of the earth. And then now let's check at this one, or let's go with this one first. And we also talked about the core logging, the tools that are needed. We will also need to understanding of what you call the core logging. Then when you're looking at different depth, okay, then you're gonna understand the heterogeneity, because we're moving from the top to bottom. Then you're gonna understand the heterogeneity of these rock layers. Then also here, because of these bedding planes, then but when you're looking from the top to the bottom, and in the field, when you're observing this on the field, then you see the heterogeneity. But now here, when you're moving or when you're looking at one layer, and then we see a lot of the homogeneity. All right. And then now we also have to understand what you call the unconformities. Okay, so let's look at this one. We had initially we know that the layers initially they must be deposited horizontally in all directions, and then but now if we compress them, they would now start to be folded like that. Then with time, this top part gets to be eroded, undergo weathering and erosion, which is why the top part it was now being eroded. And then now then the new sediments now get to be deposited on top, or any other thing get to be deposited on top. Now this is what we call an unconformity. So now this line will be an unconformity. This will be an unconformity. The line unconformity, it means a period of non-deposition, a period of non-deposition. So it means now, can you now understand that this fold was going up like that? Instead of continuing, instead of when here it was going up, but it was cut out, but it was interrupted by the erosion. Now it's going back again when it was interrupted. So which is why we need to understand this homogeneity and the heterogeneity. And then other thing, let's check at the faults. And then when we're looking at the axial surfaces or the hinge lines over here, they are continuous. Over here they are continuous, but here they are discontinuous. They are discontinuous. All right, so the hinge line of a fold is this one. So if we can check here, they are discontinuous. All right, or the axial planes, they are also discontinuous. So the hinge line, it divides the limbs. Okay, it divides the limbs of the fold, and this is the hinge zone. All right, so okay, if we can check over here, this layer over here can be continuous, but if now we start to have the hinge lines which are the axial surfaces which are discontinuous, and then we start to have a different scenario. So which is why we say you need to understand the homogeneity and the heterogeneity when you are in the field as a structural geologist, so that you can come up with the conclusion which is reasonable. Okay. Common field observations that indicate continuity: unbroken sequences of rock units. They must not be interrupted. They must not be interrupted. All right. And then consistent orientations. Okay. consistent orientations of rocks or structures over distance suggest continuity. I showed you some joints initially that were continuous, all right, and then gradual changes. And then when we say gradual changes, let's say we see the colors that are changing gradually. They must not be abrupt, but they must change gradually. Let's say from yellow to a light yellow. Then we know the colors are changing gradually. Then we know now we are still showing or seeing what you call the continuity. These things we're going to be seeing them when we are in the field. All right. Yeah, you can now see that we've got some persistent joints. Okay, then we've got some persistent joints, and then of course and then also the orientation. If these joints, if the fractures, remember we talked about the consistent orientations. Okay, if the fractures are just parallel to one another, they are consistent and they are not interrupted. But if they start to cross cut one another, they become they become interrupted. All right. Okay, that's why we're saying consistent orientation of rocks or structures. In this case, we'll be talking about structures. Okay, and then and so we need these for example, these joints to now, they must not be if they're like this, if they are cross cut, they can be interrupted. But one may say, but I don't see interruption. But now let's check a scenario wherein this point or this part, it's no longer here. Then we expect this to join that one, and then we no longer see that. All right. Yes, so that's why we see consistent orientation. And just give you an example, using what we call the joints. So over here you can see those joints that which are consistent, which shows what you call the continuity, but others they show discontinuity. Then if you can see the layers of the foliations, they are continuous throughout. They are continuous throughout. They are continuous throughout these gneissic bands. They are continuous, showing what you call the continuity. Now, for the discontinuity, you must see changes in rock types. Okay, when you're looking at the bedding planes, you're gonna see the changes in the rock types, and then you can see that we see some faults, some faults and fractures, and then they also suggest what you call the discontinuity. And then you can also see what you call some unconformities. We've got different types of unconformities, and then we also have lesson covered for unconformities into the MJ School of Mining and Geology private tutoring. We've mentioned all these types of unconformities. If you haven't yet visited that, you are more than welcome to also visit that. So unconformities, they are just a period of non-deposition. Then now they show the discontinuity. Right? They show the discontinuity. We've got so many types of unconformities, but all those unconformities, they show what we call the discontinuities. So if we can check over here, we see the fault. We see the fault. We see the fault. So we see the fault, and then this fault is very okay. See this fault. Right, but now if we moving from here to there, we are observing these kind of rocks, metamorphic rocks, but when we're here, we see over here at this contact, we see the abrupt change. So can now see, we see what you call the discontinuity. But if you were to move from here to there, you're gonna see the homogeneity, and of course you're gonna see the continuity. But if you're moving from here to them, we see the heterogeneity and we see the discontinuity. But now also there are fractures. So one may agree with me that say this was continuous with hopefully that, then what is the missing part over here? Where is the missing part? So you can now see that the fractures, they're also showing the discontinuity. And then also the faults, okay, this fault. You'd agree with me that maybe this layer, it was supposed to now be somewhere here. And then now, due to faulting and then due to the relative movement of the foot wall and the hanging wall, depending on what kind of fault are you looking at, depending on the reverse, or whether you're looking at the reverse fault or the normal fault. And then the layers, the hanging wall can either go up or can either go down. And then yeah, so also they show the discontinuity because they've disturbed. Now look at this layer, let's say it moved over here. Okay, it was no longer here, it moved over here. Then now I expect this layer to continue, but I don't see it anymore. All right, now also the erosions, they signify the discontinuity, the creation of some valleys. They signify some discontinuities. And then can now also see the abrupt change, the abrupt change. Look, you see the abrupt change, and then it should also shows what you call the discontinuities. So when you are in the field, you have to be understanding all these structural geology terms, so that you know you're gonna enjoy to be in the field, because you know what is expected of you when you are in the field. Okay. um yeah, so this brings us to the end of the structural geology lecture, wherein we're dealing with the continuity and the discontinuity. So you'll let us know what other chapters or topics can we cover, and then which will be part of our series into the structural geology. Until next time, we'll meet on the other side. Until next time, cheers.